All right, today we are moving on in Unit 6. Today we're going to be talking, instead of perpendicular bisectors, we're talking about angle bisectors. So an angle bisector is a line, a segment, or ray that cuts an angle exactly in half and creates two congruent angles on either side of it. So if a point is on the bisector of an angle, then it is equidistant from the sides of that angle. So in this picture, if ray BF bisects angle DBE, then segment FD is perpendicular to ray BD, and segment FE is perpendicular to ray BE. Then we would say that segment DF equals segment FE. Now the opposite of that is true as well, the converse of the angle bisector theorem. So if we have a point that is in the interior of an angle, and it is equidistant from the sides of the angle, then it is on the bisector of the angle. So if segment FD is perpendicular to ray BD, and segment FE is perpendicular to ray BE, and we have that segment DF equals segment FE, the length of those, then ray BF, we would say, bisects angle DBE, and therefore angle DBF is congruent to angle EBF. So, the way we use the angle bisector theorem, we're asked to find QT. Well, we're told that ray RT is the angle bisector of angle QRS. So that means that QT is equal to ST. All right, QT equals ST, and therefore 4x plus 8 is equal to 9x minus 7. And we can subtract 9x from both sides, get negative 5x. We can subtract 8 from both sides, get negative 15. And divide both sides by negative 5, and we get that x is 3. So QT is equal to 4 times 3 plus 8, or 20. So we're going to do this again with SP. We can find SP by just saying that, well, looks like JS has bisected angle MJP because angles MJS and angles PJS are congruent. So that means that 3x plus 5 is equal to 6x minus 7. So if I subtract 6x from both sides, I get negative 3x. Subtract 5 from both sides, I get negative 12. So x is equal to 4. And SP is going to be 6 times 4 minus 7, so that's 24 minus 7, or 17. So SP is 17. And I can double check that, actually. If I were to do 3 times 4 plus 5, so in other words, plug in the x to both segments, if my x is incorrect, I'm going to get a different answer for this second one. I should get something else. So, but 3 times 4 is 12, and 12 plus 5 is 17. So therefore, I have the same answer, so I have the right answer. All right, and this works the other way as well. Like we said, this is the converse of the angle bisector theorem. Because segment WX is congruent, or is perpendicular to segment Y, to ray YX, and segment WZ is perpendicular to ray YZ, and WX is equal to WZ, so they're both 5 units long. W is equidistant from the sides of angle XYZ. So by the converse of the angle bisector theorem, we could say that ray YW bisects angle XYZ. So something is congruent to angle XYW, and that something would be angle ZYW. And the measure of angle ZYW is going to be equal to the measure of angle XYW. That is the definition of congruent angles. And the measure of angle ZYW is equal to 38 degrees because the measure of angle XYW is 38 degrees. So now we are going to use that theorem. So let's see, looking here, we can see that segment JL is congruent to segment ML. They're both perpendicular, so it looks like we have a an angle bisector. So that means that angle JKL is congruent to angle MKL. So that means the measure of angle JKL is equal to the measure of angle JKL, or MKL, sorry. And that means the measure of JKL is equal to, we can substitute in that 37 degrees. All right, so because a triangle has three angles, that means it also has three angle bisectors. The angle bisectors of a triangle are concurrent. That means they intersect at a single point, and their point of concurrency is called the incenter of a triangle. So last time we talked about perpendicular bisectors. They have, their point of concurrency was the circumcenter. This is the incenter. The angle bisectors of a triangle intersect at a point called the incenter that is equidistant from the sides of the triangle. So if P is the incenter of triangle ABC, then PD is congruent to PE, which is congruent to PF. So all three of those greenish blue lines there are congruent. So, since P is the incenter of XYZ here, we are told that, so we can assume that is true. That means that segment XP bisects angle LXK. And segment YP bisects angle KYJ. And segment ZP bisects angle LZJ. So the measure of LXK is equal to 2 times the measure of PXK. So the measure of LXK is equal to 2 times 24.6, or in other words, 49.2. Likewise, the angle KYJ is equal to 2 times the measure of angle PYJ. So the measure of KYJ is equal to 2 times 25.1, or 50.2. So we can find the measure of LZJ using the triangle angle sum theorem. In other words, the measure of the three angles are going to add up to equal 180 degrees. So the measure of LXK, which is 49.2, and the measure of KYJ, which is 50.2, and the measure of LZJ add up to equal 180. Well, all I need to do now is add those two things together to get 99.4, and then subtract that from 180 to get 80.6 degrees. So the measure of LZJ, that's the big angle in the bottom left-hand corner of our triangle, is equal to 80.6 degrees. Now, because angle ZP, or segment ZP, bisects angle LZJ, then 2 times the measure of angle LZP is equal to the measure of LZJ. That means that if I divide both sides by 2, I'm left with the measure of LZP is equal to 1/2 the measure of LZJ. So the measure of LZP is equal to half of 80.6, or we come up with 40.3 degrees. And that is the answer we are looking for there, 40.3 degrees. So we're going to use this theorem to find the measure if J is the incenter of ABC. So if J is the incenter of ABC, we're asked to find JF and the measure of JAC. Well, JF is that side length right there. So we're asked to find side J, or segment JF. And I know that segment JF is congruent to segment JD and segment JE because of the incenter theorem. So because those are congruent, if I can figure out either JE or JD, I could figure out JF. Well, I could actually figure out JE pretty easily using the Pythagorean theorem, because I know that JE squared plus EA squared is going to be equal to JA squared. And I know that EA squared, I don't know anything about JE, but EA squared, or EA is 9.4, and JA is 10.6. So if I can do 9.4 squared, I get 88.36. And if I do 10.6 squared, I do 112.36. And then subtract 88.36 off of both sides, gets me JE squared by itself. And it's equal to 24. And again, I don't want JE squared, I want JE by itself, so I need to take the square root of both sides. So JE is equal to the square root of 24, which is 4.9 approximately, or exactly 2 square root 6. Now, that is JE. Well, JE and JF are the same length. They are congruent because of the in-center theorem. So that means that JF, we can substitute in, is also 4.9, or 2 square root 6. Now, the other thing we're asked to find is the measure of angle JAC. The measure of angle JAC is this angle that goes between the blue lines there that I highlighted. So again, what we're going to do is we're going to use that triangle angle sum theorem. So 2 twice times the measure of angle DBJ, which is 33.9, plus twice times the measure of angle DCJ, which is 28.5, plus the measure of EAF, or BAC, is equal to 180. Well, 2 times 33.9 is 67.8. 2 times 28.5 is 57 degrees. So 67.8 plus 57 is 124.8. So if I subtract 124.8 off of both sides, let's see here, 180 minus 124.8 gives me 55.2. That gives me the measure of BAC, which is the whole angle. I don't want the whole angle, I want just half of it. So the measure of JAC is just going to be half of that. So 55.2 divided by 2 is 27.6. All right, so next, find each measure if G is the incenter of ABC. So GAF is what we're asked to find first. Okay, again, same thing. So that's going to be 2 times 42 plus 2 times 30 plus the measure of angle BAC equals 180. So 2 times 42 is 84. 2 times 30 is 60. 84 plus 60 is 144. And so the measure of angle BAC is equal to 180 minus 144, which is 36. But we don't need the measure of BAC, we need the measure of GAF, so that's going to be half of that. So that is going to be 18 degrees. Now segment EG is going to be congruent to segment DG and segment FG. So if I can figure out one of those segments, it looks like I can figure out segment GF pretty easily. If I do 7.12 squared plus GF squared equals 7.49 squared. So 7.12 squared is 50.6944. And 7.49 squared is 56.1001. So subtract 56.1001 minus 50.6944. We get 5 GF squared is equal to 5.4057. So the square root of both sides gives us GF equals 2.3, we're gonna round up to 3. So 2.33. All right, that does it for today's lesson. If you have any questions, shoot me an email or a Canvas message, and I will get back to you as quickly as I can. Have a great day.